Hi, hello everyone. Welcome to SK Academy of Mathematics. Today, let us learn how to solve the eigenvalues and eigenvectors given with respect to the matrix 220, 250, 003. Let us find first representing matrix, that is A, which is equal to 2, 2, 0, 2, 5, 0, 0, 0, 3. Then to find the eigenvalue, the characteristic equation is given by is given by determinant of a minus lambda I equal to 0. That is determinant of a minus lambda I, which is equal to 2 minus lambda 2 0 2 5 minus lambda 0 0 0 3 minus lambda, which is equal to 0. Done. Now do the determinant matrix multiplication. 2 minus lambda into 5 minus lambda into 3 minus lambda minus 0 minus 2 into 2 into 3 minus lambda 0 into 0 0 plus 0 into anything, the whole term will be equal to 0. So this is equal to 0. Done. Now 2 minus lambda into 5 minus lambda into 3 minus lambda, minus 2 into 2 minus 4, 3 minus lambda equal to 0. In these two terms, 3 minus lambda is common. Consider 3 minus lambda into 2 minus lambda, 5 minus lambda minus 4, which is equal to 0. 3 minus lambda into 5 2s are 10, 2 into minus lambda minus 2 lambda minus 5 lambda plus lambda square minus 4, which is equal to 0. 3 minus lambda into lambda square minus 2 lambda minus 5 lambda minus 7 lambda, 10 minus 4 plus 6, which is equal to 0. Factorize this term, you will get the roots, that is 6 lambda square. That is how to simplify? If you get 6, that is 3 2s are 6. We are getting 5 2s are 10. To get 6, okay, 6 lambda into 1 lambda. Since I need to get minus 7 lambda minus plus 6 ones are 6, lambda into lambda square, that is 3 minus lambda. Just I am going to interchange lambda square minus 1 lambda minus 6 lambda plus 6 equal to 0. Now that is 3 minus lambda into lambda minus 1 minus 6 into lambda minus 1, which is equal to 0. Now representing the equation, 3 minus lambda into lambda minus 1 into lambda minus 6, which is equal to 0. That is lambda minus 1 into 3 minus lambda into lambda minus 6 equal to 0 is the characteristic equation of the given matrix, let us write it as a matrix. Done. Now the roots are lambda 1 equal to 1, lambda 2 equal to 3, lambda 3 equal to 6 are the eigen values of the given matrix Considering these eigenvalues, we are going to find the corresponding eigenvector. How we are going to find? Let us see. Before that, let us consider the matrix. Consider matrix A minus lambda I into x, which is equal to 0. What we are going to find in the eigenvector? The number of unknowns. How? That is, what is A minus lambda I? 2 minus lambda, 2, 0, 2, 5 minus lambda, 0, 0, 0, 3 minus lambda into the unknowns x, y, z, which is equal to 0, 0, 0. Done. Now, case number 1. What is our case number 1? That is lambda equal to, consider this as equation number 1. Lambda equal to lambda 1 equal to 1. First case is our 1. If you simplify in equation number 1, that is matrix A minus lambda I into x1, which is equal to 0, that is 2 minus 1, 2, 0, 2, 5 minus 1, 0, 0, 0, 3 minus 1 into x, y, z, which is equal to 0, 0, 0. Now, after simplify, you get 1, 2, 0, 2, 4, 0, 0, 0, 3 into x, y, z, which is equal to 0, 0, 0. Done. Since we have, see, first row and second row are same. If you divide second row, you will get the first row. Just represent this in the linear equation form. You will get the solution. That is x plus 2y equal to 0. Second row is same as first row. So I am going to consider only first row. Next, the last row, 3z equal to 0. Equation number 1 and equation number 2. That is z equal to 0. But to satisfy, to find unknowns x, y, I need to take some constant so that LHS and RHS should be equal to 0. How to satisfy? Since I need to consider a constant value so that x and y should satisfy. So what I am going to do? I am going to represent x plus 2y equal to 0. That is x equal to minus 2y. Consider y equal to k1. Then x equal to minus 2 k1. This is the value of x and this is the value of y. Since always remember, the unknowns x, y, z should not be equal, every element should not be equal to 0. At least one variable, either any one variable should be other than 0. Then therefore the x1, which is equal to x, y, z, which is equal to minus 2 k1, k1 and z equal to 0 is the eigenvector, corresponding to the eigen value when lambda equal to lambda 1 equal to 1. Got to know first case? No. Similarly, let us find the case number 2. What is our case number 2? Case number 2 is lambda equal to lambda 2 equal to, what is the case number 2? 3. In where? In equation number 1. Which is our equation number 1? This is our equation number 1. So that is matrix A minus lambda I into x2, which is equal to 0. That is, what is A minus lambda I? 2 minus 3, 2, 0, 2, 5 minus 3, 0, 0, 0, 3 minus 3 into x, y, z, which is equal to 0, 0, 0. Done. Now just simplify. 2 minus 3 minus 1, 2, 0, 2, 5 minus 3, 2, 0, 0, 0, 0. See, this is our condition, that is x, y, z, which is equal to 0, 0, 0. Now we don't have the last row. Since we don't have last row, now let us find x and y. First, let us find x and y. Represent this first row and second row with respect to linear equation form. That is minus x plus 2y equal to 0. Equation number 1. Next, 2x plus 2y equal to 0. Equation number 2. Solve equation 1 and 2. Solving equation 1 and 2, what we are going to get, that is minus x plus 2y equal to 0, 2x plus 2y equal to 0 whole divided by minus just plus 2y minus 2y get cancelled, minus 3x equal to 0, x equal to 0. Since x equal to 0, then y is also equal to 0. But what is the value of z? Since we don't have the z row to find, so what we are going to consider? Consider a constant term, that is z equal to k2. Okay, where for all k2 belongs to set of all real number r. K2 belongs to set of all real number r. Here also for all k1 belongs to set of all real number r. Done. This is the case number 2 solution, where x2 which is equal to x, y, z, which is equal to, what is the value of x? Value of x is 0. What is the value of z? Y 0. What is the value of z? K2. Always remember, whatever we are going to find the unknowns, whether it may be x, y, z, the variables, every term should not be equal to 0. Should not be equal to 0. This is the first condition. This is the eigenvector corresponding to eigen value when lambda equal to lambda 2 equal to 3. Now done with case number 2. Now let us find case number 3. How to find case number 3? Same to same. Now let us find case number 3. Case number 3. Case number 3, that is lambda equal to lambda 3 equal to 6 in equation number 1, that is matrix A minus lambda I into x3 which is equal to 0. What is our equation number 1? This is our equation number 1. Now let us simplify this, that is 2 minus 6, 2, 0, 2, 5 minus 6, 0, 0, 0, 3 minus 6 into x3, the unknowns x, y, z, which is equal to 0, 0, 0. Done. Now simplify. 2 minus 6 minus 4, 2, 0, 2, 5 minus, okay, 5 minus 6 minus 1, 0, 0, 0, minus 3. If you check first row and second row, again first row and second row are same. Why? Because if you divide first row by 2, you will get minus 2, 1, which is same as second row. So what I am going to do, just I am going to consider the equation number 1, that is minus 4x plus 2y equal to 0. Next, the last row we have minus 3z equal to 0. Equation 1 and equation 2. I have represented the matrix in the linear equation form. Now, since minus 3z equal to 0, consider 3z equal to 0, z value is equal to 0. Now, in the first equation, consider equation number 1, that is minus 4x plus 2y equal to 0. 2, take the components, 2 minus 2x plus y equal to 0, minus 2x plus y equal to 0. Now what I am going to do, consider y equal to 2x. Y equal to 2x. Now I need to consider the constant term x so that I am going to get y. To get y, what we are going to consider? Consider x equal to k3, then y equal to 2k3. See, if you want, you can check it. See, what is minus 2x plus y equal to 0. Minus 2, what is the value of x? K3, plus what is the value of y? 2k3, which is equal to 0. Minus 2k3 plus 2k3 get cancelled. LHS equal to RHS. Condition satisfies? Yes. Therefore, x3 which is equal to x, y, z, which is equal to, what is the value of x? K3. What is the value of y? 2k3. What is the value of z? 0. Where for all k3 belongs to set of all real number r. What does it mean, set of all real number r? If you give any value with respect to k3, either it may be real number, rational, irrational, integer. If you simplify any number, LHS will be equal to RHS for any equation. This is the term. Okay, is the eigen vector corresponding to the eigen value when lambda equal to lambda 3 equal to 6. See, we have find case 1, case 2, case 3. For considering the first, consider the matrix, represent this matrix with respect to determinant of a minus lambda equal to 0. Simplify, you will get the characteristic equation. Considering those characteristic equation, we are going to represent the roots. Considering those roots, we call it as eigenvalues. Considering those roots, we are going to represent the eigenvectors with respect to case 1, case 2, case 3, where with respect to case 1 we have got minus 2k1, k1 plus 0. If you check here, you will get LHS will be equal to RHS. Case 1 is completed. Similarly, with respect to case 2 and case 3, whatever you are getting, the eigenvectors corresponding to the eigenvalues will be satisfied. If the LHS equal to RHS with respect to eigenvectors, we call it as the given eigenvectors. I hope you have understood this problem step by step. For more videos, please do like, share and subscribe. See you in the next video. Thank you.